Generative Theories of Interaction. This article was published in the ACM Transactions on Computer-Human Interaction in December 2021 by Michel Beaudouin-Lafon, Susanne Bødker, and me, Wendy Mackay. First, what is generative theory, and how does it contribute to research in human-computer interaction? The natural and social sciences involve an ongoing cycle between theory and empirical observation. Some sciences, such as experimental psychology and classical physics, begin with theory when they present their research, which they then test empirically, often with controlled experiments, the results of which allow them to revise their theories accordingly. Other sciences, such as anthropology and astronomy, first describe naturally occurring phenomena that they observed, which they then explain with theory that is tested empirically with other user populations or related phenomena. HCI research clearly involves this back-and-forth cycle between theory and observation. However, it also includes the design and study of novel artifacts, making it what Herb Simon calls a science of the artificial. We are not unbiased observers of independent natural phenomena. Instead, we theorize about and observe what we design ourselves. If we examine current human-centered design methods, we see that they focus on empirical observations of users, either to inspire design ideas or to test them. However, we also see an important opportunity for theory-driven design, which benefits from a vast existing literature from other sciences about human beings, their interactions with each other, and with artifacts in the physical world. This paper introduces a methodology for creating generative theories of interaction, which we hope will not only inspire other researchers to generate new theories of interaction, but ultimately help practitioners generate novel interactive technology that is grounded in and benefits from our collective understanding of human behavior. So what is a generative theory of interaction? We begin with existing theories from the natural or social sciences that are relevant to HCI. These both inspire and ground the creation of HCI-specific concepts that are then operationalized into actionable generative principles. We apply three different lenses to these generative theories. The analytical lens starts by observing how users interact with existing artifacts according to a specified set of generative principles, which allows us to understand and compare them. The critical lens lets us identify problems or misdesign opportunities related to those principles. Finally, the constructive lens helps us use these generative principles to come up with new ideas and create new artifacts. We illustrate how we've productively used a generative theory approach to develop novel artifacts in our own research over the past decade. The first example is instrumental interaction, which is based on two grounding theories: human tool use and technical reasoning from paleontology and cognitive science. The second example is human-computer partnerships, which is based on two grounding theories, co-adaptation and the adjacent possible, from evolutionary biology. The third example is community and common objects, which is based on two grounding theories, activity theory and artifact ecologies, from psychology. The generative theory of instrumental interaction has, for example, the concept of an instrument, which mediates a user's interaction with an interactive system. One of its key generative principles is reification, which transforms a command into an interactive tool or instrument. We can see how this works with sticky lines, which reifies the alignment command into a magnetic guideline. Here, the user creates a sticky line that maintains the alignment of all objects that are attached to it. This alignment persists, even if one or more objects are moved. Users can also offset objects from the line, for example when the geometric center does not match the visual center. They can then reify the offset into an instrument that can be copied and pasted and used to offset other similar objects. The generative theory of human-computer partnerships is built on the concept of co-adaptation, where users must both adapt to an interactive system, they learn how it works, and they adapt it to suit their own needs. Two generative principles, discoverability and appropriability, can be combined so that users discover the capability of the system through progressive feed-forward and feedback in order to redefine and personalize the system commands. For example, we use these principles to design FieldWord, which lets users define gestures that can be used as commands. Users want commands that are easy for them to remember, but must also ensure that those gestures can be easily recognized by the system. FieldWord provides a dynamic heat map. As the user draws a gesture, the system changes color to indicate what it is recognizing. If the gesture ends in a blue zone, the gesture is unique and can be adopted by the user. If it ends in a red zone, it is not easy to distinguish from another gesture, so the user should continue or start over. The third example of generative theory is community and common objects. A key generative concept is a common object, which acts as the center of activity for a community of people. A key generative principle is malleability over time, which supports the evolution of community practice and routines with respect to common objects over time. For example, the Caseline calendar is a shared timeline designed to help parents plan their parental leave in Denmark. The timeline acts to coordinate a set of activities and objects across a variety of people with differing needs and interests that may change significantly over time. Each of these generative theories of interaction occupies a different space within the scope of possible HCI theories. Instrumental interaction is primarily focused on an individual user at a particular place at a specific point in time. Human-computer partnerships involve individuals or small groups of users who may be co-located or remote and over longer periods of time. Finally, community and common objects involve large groups of users or whole communities located in many different places over significantly longer periods of time. But clearly, these three examples only touch on a small part of the large potential space of theory for human-computer interaction. We call upon our fellow HCI researchers to draw from existing theory in the natural and social sciences, such as distributed cognition or boundary objects, or to use theory generated from within the HCI community to create powerful new generative theories that inform interaction design.